Look at the cuboid below. Draw two more faces to complete the net of the cuboid. So if this face here is our base, this face will fold up, this square face will fold up and so be one of the squares at the end, and then when this square has folded up, this rectangle will be able to fold all the way over the top. But we need a face here because we need to cover this edge, and if we have a square face at this end, we'll need a square face at the other end as well. Here are 5 shaded triangles on a square grid. Write the letter of each triangle that has a right angle. So remember, a right angle is like the corner of a piece of paper or the corner of this screen. So we have a right angle here because that's the same size as the corner of a piece of paper, so we can write C, but we also have a right angle here. And the way that we can tell that this is a right angle is because from this point, if we go across one and up, we get to the line, and across one and down, we get to the line as well. So we go across and then either up or down by the same amount. So D has a right angle as well. Now you might think perhaps this angle here looks a bit like a right angle, but remember the way to check, we can go across one and up one to get to the line, but then we need to go across one and down two to get to the line. So we're not going across and down by the same number. Now write the letter of each triangle that has 2 equal sides. Remember, a triangle with 2 equal sides is called an isosceles triangle. And we can see that this side is the same length as this side, so shape A has 2 equal sides, and this side is the same length as this side, so that's shape D as well. Sarah had a bag of cherries. She ate 5 cherries, then gave half of what she had left to Liam. Liam ate 5 of his cherries, then gave half of what he had left to Amy. Amy got 2 cherries. How many cherries did Sarah have in her bag at the start? So because we want to know the total at the start, we need to work backwards. We know that Amy got 2, and that was half of what Liam had left, and half of 4 is 2. So Liam must have had 4 cherries before he gave half of what he had left to Amy. Then, a step before that, Liam ate 5 of his cherries. So before he ate 5 of them, he must have had 5 more, and 4 plus 5 is 9. So Liam had 9 cherries, he ate 5 of them, so that meant he had 4, and then he gave half of that, so gave 2 to Amy. A step back from that, Sarah gave half of what she had left to Liam. So we know that Liam had 9 cherries, and half of 18 is 9. So Sarah must have had 18 cherries before she gave half of what she had left to Liam. And Sarah ate 5 cherries, so before she did that, she would have had 5 more, and 18 plus 5 is 23. So that means Sarah must have had 23 cherries at the start. Another way to solve this question is to draw a diagram. So Sarah had a bag of cherries. We don't know how many, but we know that she then ate 5 cherries, so that would have been 5 less or minus 5. She gave half of what she had left to Liam, and to find half, we divide by 2. Liam ate 5, so that's subtracting 5, and then gave half of what he had left to Amy. So if he's giving half away, that's dividing by 2. And we know that Amy got 2 cherries. So now we can work backwards. 2 times 2 is 4, so 4 divided by 2 is 2. 4 plus 5 is 9, so 9 minus 5 is 4. Notice here, when we're working backwards, we're using the inverse or the opposite. So instead of dividing, if we're going this way, we're multiplying, and instead of subtracting, if we're going this way, we're adding. Then something divided by 2 is 9, so that's 18, because 9 times 2 is 18. And then something minus 5 is 18, so that's 23. Here is a shaded shape on a 1 centimetre square grid. What is the area of the shaded shape? So we need to count the number of squares inside the shape, because the area is how much stuff there is on the inside. Remember, the perimeter is the distance around the outside, but the area is how much space a shape takes up. So we can see that here we have half of 2 squares, so that's the same as 1 square shaded. And here again we have half of 2, so that's another one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the area is 10 centimetres squared. Here is a grid of regular hexagons. The shaded shape has an area of 3 hexagons and a perimeter of 14 centimetres. So we can see that this shape takes up 3 hexagons, so that's its area, and the perimeter is 14, because if we count the number of sides, and remember the sides are 1 centimetre, we can count 14 centimetres around the outside. Now we need to draw another shape on the grid which has an area of 4 hexagons and a perimeter of 14 centimetres. So we need the perimeter to be the same. So we can't have another straight line, but this time of 4 hexagons, because if we had this hexagon shaded as well, the perimeter would be longer. So we need to shade 4 hexagons like this. That way the area is 4 hexagons, but if we count the distance around the outside, so we need to remember we're starting here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and now we're back where we started, so that's a perimeter of 14 centimetres. Draw the reflection of the shaded shape in the mirror line. So we need the same on both sides, and to work out our reflected shape, we need to dot our corners. So this corner here is on the mirror line, so it will be on the mirror line when we reflect the shape as well. To get to this point here, from the mirror line, we go to where the circle starts. So in the other direction, we go to where the circle starts and dot our corner. For this point here, from the mirror line, we go all the way across to the end of the circle. So we go all the way across to the end of the circle in the other direction. And then here we go and get to the circle. So we go across as far as the circle, and we can see that the point is at the top of the circle in our shape. So that's the top of the circle when we reflect the shape as well. So now all we need to do is join up our points and we have our reflection. Put a tick in each row to complete this table. One has been done for you. So they've told us that 0.9 is greater than 1/2. And that makes sense because the first digit after the decimal point tells us how many tenths we have, and 9/10 is greater than 1/2 because 1/2 is the same as 5/10 or 0.5. Now we have 0.06. So we need to remember that the second digit after the decimal point is our hundredths digit. So here we have 6/100ths. Now we need to compare that to 1/2. So we need to think 1/2 is the same as how many hundredths? Well, we can find an equivalent fraction, and 1/2 is the same as 50/100ths. So because 6/100ths is less than 50/100ths, that's less than 1/2. Now 11/20. We need to think 1/2 is the same as how many 20ths? 2 times 10 is 20 and 1 times 10 is 10. So because 1/2 is the same as 10/20, 11/20 is greater than 1/2. And now we have 0.21. So that's 21 hundredths, because the second digit tells us how many hundredths we have. So if we have 2 digits after the decimal point, our denominator will be 100. But 1/2 is the same as 50 hundredths. So 0.21 or 21 hundredths is less than 1/2. On this scale, the arrow shows the weight of a pineapple. Here is a different scale. Mark with an arrow the weight of the same pineapple. So on this scale, we can see that to get from 0 to 1, we have 10 lines. So each of these little lines is 1/10. So if we have 4 little lines after 1, that's 1 4/10, or 1.4. But if we look at this scale, we don't have tenths as our little lines, because to get from 0 to 1, we instead have 1, 2, 3, 4, 5 lines. So on this scale, the little lines are not tenths, they're fifths. So we need to think 4/10 is the same as how many fifths? Well, 10 divided by 2 is 5, 4 divided by 2 is 2, so 1 4/10 is the same as 1 2/5. And knowing that means that we can mark our arrow on this scale, because we know that each of these little lines are fifths. So if we have 1 2/5, that will be the second line after 1.